Hello and welcome back to the Data Unite channel. This is Seko and today we will discuss about support vector machines machine learning models. And if you like this kind of content and you want to learn more about machine learning, please make sure that you like this video and subscribe to the channel. Support vector machines is a supervised machine learning algorithm that can be used in both classification and regression problems, but it is mostly used by classification problems. The algorithm works by plotting the records of the dataset as points in an n-dimensional space, where n is the number of features or columns that we have in the dataset. And after plotting the point, it gets classified by finding the hyperplane that separates the two classes. The support vectors are basically the coordinates in the plot of the individual data point, and the SVM classifier is the boundary of the hyperplane that separates the two classes. There are some advantages when implementing the SVM machine learning models, and those are: it works well when there is a clear margin of separation between classes. It is more effective in high-dimensional spaces, which means that if we have more features, the results will be better. It is effective when the number of dimensions is greater than the number of samples. So in this case, it is a good substitute for the naive Bayes classifier that does not perform well in these situations. And at the end, it is memory efficient algorithm. On the other hand, some disadvantages are: it is not suitable for very large datasets. It does not perform very well when the dataset has noise, and as the support vector classifier works by putting the data points above and below the classifying hyperplane, there is no probabilistic explanation for the classification, and it makes it more difficult to understand the outcome. So let's see how SVM works with linearly separable data. Let's take as an example where we have two classes that are shown on the image on the right, with class A as circles and class B as triangles. And we want to classify those records by applying the SVM algorithm and find the best hyperplane that divides the both classes. There can be many hyperplanes that will separate the classes, but the best hyperplane would be the one that has the largest distance from both classes. And to determine how the hyperplane will be determined, the model uses something called margins, which basically means the distance between the hyperplane and the closest support vectors, also known as data points on the plot. There are two types of margins: soft margin, see on the image on the left, which permits few records to be misclassified, and it tries to make the balance back and forth between finding a hyperplane that attempts to make less misclassifications and maximize the margin. And the second margin is a high margin, which does not permit any misclassified records, which means that all records of one class should be on one side of the hyperplane and all the records of the second class should be on another side of the hyperplane. On the other hand, in case of non-linearly separable data shown below in the image, SVM makes use of kernel tricks to make it linearly separable and help in projecting data points to the higher dimensional space, by which they become linearly more easily separable in high dimensional space. This transformation is also called as Culver's theorem, and the kernel tricks are also known as generalized dot product, which is a way of calculating a dot product of two vectors to check how much they impact on each other. According to the Culver's theorem, chances of linearly non-separable datasets becoming linearly separable increase in higher dimensions. There is also a term called degree of tolerance. which is the penalty term that is passed as a hyperparameter in the model while dealing with both linearly separable and non-linearly separable solutions. This term is denoted as C, and large values of C result in more penalty for the model when it makes a misclassification. And in this case, the decision boundary will be dependent on narrow margin and less support vectors, meaning that the hyperplane will be very close to the data points. There are 4 types of kernel functions that can be used by SVM model. Those are linear, polynomial, radial basis function, and sigmoid function, but most frequently are used polynomial kernel, which is a process of generating new features by using a polynomial combination of all the existing features, and a radial basis function, or RBF in short, which is a process of generating new features, calculating the distance between all the other dots to a specific dot. One of the RBF kernels that is used widely is the Gaussian radial basis function. So, for example, on the left you can see some cases of how different kernels classify the same data into different ways. So this was all about the theoretical part regarding the support vector machines model, and in the next video we will see how we can implement it on a real-world classification problem in Python. Thank you for watching this video until the end, and please make sure that you leave a comment if you have any questions or if you have any requests that you would like to be covered in the next videos. Until next time, bye bye!